Alright, now we are continuing with question 18. Let's read the question. A car traveling at 21.5 meters per second brakes to a stop in 2.35 seconds. You see, reading this first line now, we can actually already imagine the VT graph. It will look something like this. It says constant deceleration, right? And then we know that you will travel at 21.5 at the start, and then you will brake to a stop in 2.5 seconds. So we know it's going to look like this. We just picture this in our minds first, okay? Then now they asked us to calculate the braking distance of the car if the car experiences a constant deceleration. So what do we need? We need braking distance. Objective. Constant deceleration is a hint. Okay, now let's start with drawing the VT graph. Okay, VT. We know the initial is 21.5 and it decelerates from here to here with a constant deceleration in 2.35 seconds. What we are looking for is we are looking for the braking distance of the car, which is this one, this area on the graph, because this is a VT graph. Therefore, the braking distance would be D equals to half because it's a triangle, 21.5 times 2.35. And you should get 25.3 meters, bracket 3SF, and you are done. Simple as that. Alright, next one. A ball free falls for 4.2 seconds from rest. The acceleration due to gravity is 10 newtons per kg. Alright, so let's get some information down here. Free falls for 4.2 seconds from rest. So we know that from rest means that u equals 0. Then we also know that a or g equals to 10. I think this one is pretty simple. So they ask what is his final velocity. We just use the simple equation of a equal v minus u over t. A is 10. V is what we want to find. So with v, it started from rest, so u must be 0. And t would be 4.2 as seen in the question. So with this, we find that v is 42 meters per second. Yes. Okay. How far would the ball fall in 4.2 seconds? The one thing about O-level kinematics is that every time they ask you how far a ball will fall, how far something will travel, it's always just them asking you to find the area under a velocity time graph. Okay, so we just draw the VT graph of just now, that motion. So this is a ball free falling. So free falling means it's constant acceleration. We just draw it like this, straight line with a constant gradient. The velocity is going up at a fixed rate. That's how we can understand it. So we know that the velocity will be 42 and the time taken is 4.2. So the distance should be half because of the triangle. 42 to 4.2, we will get 88.2 meters, and that's all. Okay, let's move to question 20. Okay, the diagram shows a ball being thrown upward with an initial speed of 8 meters per second from a cliff. Alright, so in this one I didn't draw the diagram but I will draw it right now. So a ball being thrown upward and then it will fall off the cliff, so we can just draw it like this. Pretty simple. Like this. Then after it, what information do we have? We know that the initial speed is 8 meters, so we just draw 8 meters per second square. And this is not to be confused with an initial highest height of like 8 meters. Like a lot of people will like do this because they saw 8 meters. I mean, yeah, it's just pure carelessness at that point, so try not to make that mistake. Calculate the height of the cliff. This is the first one. As I just said earlier, when they ask you to calculate the height or the distance somehow, what are they asking for basically? They are indirectly asking you to draw a VT graph. Okay, this question is a bit more difficult, so if you need more time, you can take a break, go drink water or something first, then come back and listen to this explanation, okay? But if you're ready, let's draw the VT graph. In this case, the VT graph will be one that has both positive and negative because the ball will change direction after it reaches its peak. So we draw it like this. Yes. The ball has an initial speed of 8. Then, as it reaches its peak, at this point, it will go down like this. Then at that time, after that, yes, it will accelerate, but in the opposite direction. No, sorry. Yes, it will accelerate in the opposite direction of its previous motion. Therefore, the line will just continue into the negative as it has now changed direction. So we know that the ball takes, from the question, we know that the ball takes 6.5 seconds to reach the ground. Therefore, we can write 6.5 here. And what do we need? We need to find the height of the cliff. So I think one thing we need to understand right now is that if the ball goes up, it also has to come down. See, let me show you. A lot of students, they will take this entire area to be the height of the cliff, but then they will just get it wrong. Because you see for this area, let's highlight this area actually. Let's call this the green area. Let me show you what this green area actually means in the diagram. This green area actually represents this entire height. But are we looking for this height? No, we are not. We are looking for the height of the cliff, so we need this. So somehow we need to cancel out this yellow excess. So what we are looking for is actually the pink area, which is something like this. If you can, yes, it looks something like this. Basically, this green area has to cancel out this other green area in the graph, so that like it went above the cliff, it also has to go back past its starting point. If you don't understand, you can always email the email that is associated with this channel anyway, so don't worry about it. Alright, so one thing is that we need the velocity here and here, and we also need the time here and here. So we have a lot of things to find. This question is actually pretty hard. So the first thing we're going to do is we're going to find the two times, because the two times will eventually help us to find the two velocities later. Don't understand, don't worry, just bear with me first. We just start with the idea that anything going up, the time taken for it to go up will also be the same time taken for it to go down. So we know that for this time, this one will just be double of it, because this is the same one, the same time. So we know okay, so now let's focus on this starting point, like this part of the motion. It goes up at a initial speed of 8 meters per second, right? We just take acceleration equals to final minus initial, final being 0 as it's at the top, initial being 8 over time, and then acceleration is -10 because it's pointing down, while this question is associating upwards with positive. So it will be -10 equals to 0.8 over t. Therefore, t will be 0.8 seconds. So this will be 0.8 seconds, and you know that this time interval is the same for going down also. Therefore, this will be 0.8 seconds after 0.8 seconds, and therefore this will be 1.6 seconds. So we have found out the times we need for this trapezium shape that we need to find area under graph. Now we just need to find the speed. We know that this speed, using some symmetry or common sense, we know that this speed will be 8 or -8 if you want to look at velocity. But what about this one? This one we need to know how long exactly it has been in free fall. So we know that the free fall starts at the 0.8 mark, as you can see from the constant acceleration line like this. Therefore, we need to use the equation again. A equal to v minus u over t. The acceleration is -10. The final velocity we do not know. The initial velocity should be -8, and the time taken should be, the initial velocity should be 0, and the time taken should be 5.7. Therefore, the v should be -57, or the speed is 57, because speed is just velocity without its direction. It's a scalar version of it. So we can write -57 here. So now we can finally solve the question. They say calculate the height of the cliff. Okay, I'm gonna bracket this because this is the answer. I know I write a lot of A's, you're confused for acceleration, but it's okay. just focus on this one lah. Okay, so now we need to find the height of the cliff. We know that it is actually this area. Okay, it's a trapezium. So what's the formula for trapezium? We can actually take half times the sum of the two heights. These are the two heights, so 8 and 57. So 8 and 57, we do quick math, is 65. Then after that we need to find the common length, which is this one. So it will be 4.9, yes, like this. And therefore we get an answer. We will end up with an answer of 159 meters. Bracket 3 significant figures, and we are done. And then for part B, right, we actually solved it just now already. It's pretty simple. Calculate the speed of the ball as it hits the ground. They ask for the speed, so can you give a negative answer? No. As it hits the ground. So it hits the ground means this part lah. This part. Yep. So we already got the answer actually, but we just present another working lah. A equal V minus U over T. Then the A we just write 10 lah, since it doesn't really matter. The direction doesn't matter. V minus U, U being 0 over 5.7. Then can we write V equals 57? No, they asked for initial speed, so we just copy what they asked. Initial speed equals 57 meters per second.